Section 9.3 deals specifically with geometric sequences. We've talked about arithmetic sequences. What makes something arithmetic? What do you have to have for an arithmetic sequence? There has to be a common difference. What does that mean? How are the numbers being generated? What? Recursive is a type of sequence, a type of formula for a sequence. But for an arithmetic one, if it has a common difference, that means to get from one term to the next, you are doing what operation? Subtracting or adding, right? Arithmetic, you're adding or subtracting to go from one term to the next. And it has to be constant. So I might have a sequence where I'm always adding 5. Or I might have a sequence where I'm always subtracting 3. Okay? Shifting to geometric ones, we're going to look at being able to define, identify, and apply those. So what makes something a geometric sequence instead is that you're using multiplication or division. So arithmetic, you're adding and subtracting. Geometric, you're multiplying or dividing. And remember, dividing is the same as multiplying by a fraction, right? So we typically say arithmetic is adding, geometric is multiplying. So you have two versions again. With it being geometric, we don't have a common difference anymore. We have a common ratio. Okay? So in our formulas, instead of using a D, we're going to be using an R for that common ratio. We can figure out what the R value is by taking any term and dividing by the one in front of it. So second term divided by the first term, 10th term divided by the 9th term. All right, that will be how you're calculating your R value. In a geometric sequence, we have a first term, and then each time after that, we just keep multiplying by another R. Just like with arithmetic, we kept adding another D. Okay? The nice thing about an explicit formula is there's really not much simplifying to do. We dump our numbers in and we're done. With arithmetic, we did have some distributing, combining like terms, kind of cleaning that up. Geometric, typically, we don't have that. So for an explicit geometric formula, the nth term, right, any term in my sequence, is going to be found by taking the first term, and we're timesing by R, but we're doing that n minus 1 times. Okay? We already have our first term. We don't have to multiply R to get it. So the second term, we just multiply by 1 R. The 10th term, we would need 9 R's. Okay? So a sub 1 times R to the n minus 1 power. For our recursive rule, remember there are two parts to it. We always have to state the first term. All right, we have to give the person looking at it a way to get this sequence started. And then we're going to take what? What did we refer to a sub n minus 1 as? What? Previous term, yep. So to get any term in a recursive rule, or in a geometric sequence, any term can be found by taking the previous number and just multiplying by R. All right, so we're going to start out just looking at, is this geometric? If it is, we want to find a sub 1 and R. I believe there's a typo in your notes packet, that weird symbol thing. Change that to an a sub 1. So my first step is to figure out, is there a common ratio? If there is, I can take any term and divide it by the previous one, and I should get the same answer. So checking on this one. 6 divided by 3 is 2. 12 divided by 6 is 2. 24 divided by 12 is 2. 48 divided by 24 is 2. So we're getting the same answer every time. That tells me my R is 2, my common ratio. So this is geometric. My first term was 3, and my R value was 2. Okay. Could I write a formula for it if I know those two things? Yes. If I'm going to write it explicitly, a sub n equals my first term times my R value to the n minus 1 power. If I want to write it recursively, I state the first term, and then I say the nth term is the previous number multiplied by 2. All right. Take a minute at your tables and check the next one. Is it geometric? Is there a common ratio? All right. Is our second one geometric? No? If you try the first few numbers, 6 divided by 3 is 2. Is 9 divided by 6 equal to 2? No. So we're not getting the same thing each time. It's not geometric. What is it? It is arithmetic, actually. What's your common difference? 3, right? We're adding 3. So not arithmetic, or not geometric, but arithmetic. The next one is written in a slightly different form than we're used to seeing. We have 3 to the 5th, 3 to the 10th, 3 to the 15th, 3 to the 20th. To check if it's geometric, we always take a term divided by the previous term. What do we get if we take 3 to the 10th divided by 3 to the 5th? We get 3 to the 5th. What do we get if we take 3 to the 15th divided by 3 to the 10th? We get 3 to the 5th. Same thing with 3 to the 20th divided by 3 to the 15th. So what does that tell me? It is geometric. What is my R value? It is 3 to the 5th. What is my first term? It's also 3 to the 5th. Now, if we were to write an explicit rule for this, we start with a sub n equals my first term times my R value to the n minus 1 power. That's actually something we can kind of clean up. What happens when we have a power to a power? Power to a power, we multiply them. So 5 times n minus 1, if we distribute that, we get what? Okay, so now we have 3 to the 5th times 3 to the 5n minus 5. We have common bases. In both cases, they're 3's. What happens when I have a base to a power times the same exact base to a power? Now I add the powers. What do we get when we take 5 plus 5n minus 5? Just 5n. So this actually simplifies down just to be 3 to the 5n. Most of the time, your first term and your base aren't the same, so you can't simplify it, but in this case we could. What would our recursive rule look like? We start with what? When we write a recursive rule, we always start with identifying the first term. First term in this case is 3 to the 5th. Okay? Every term after that is followed by doing what? Previous term times a 3 to the 5th, right? Times our R value. Okay? So it can be written both explicitly and recursively. All right, I'm going to pause the video for a sec. I want you guys to grab that green sheet that you've been writing your formulas down on and go ahead and get the three boxes filled in for geometric. Our next question deals with finding a specific term in a geometric sequence. It says, what are the indicated terms? In the first one, we want to find the 10th term. First of all, do you agree it's geometric? What is the R value that we're seeing? Okay. And I'm going to write it down here, even though we can do this part in our head, because it's not always going to be an integer. I might give you an R value of 3.125. Okay, it's not going to be as obvious. So just remember, you can always take the second term divided by the first. If I just said, give me the nth term, not the 10th term, if I just said, give me a rule for the nth term, we would write it explicitly. Those are more useful. All right. If we want the 10th term in a recursive one, that means we have to find all the other 9 first. Okay, so explicit is easier here. We take our first term times our R value to the n minus 1 power. Well, they are specifically saying find the 10th term. So we are asked to find a sub 10. That means we have to plug a 10 in for n, which means my power is going to be 9. All right, so grab your calculators. What is 4 times 3 to the 9th power? All right, I heard 78,732. Agree?
Yes.
Question for you. Is that the same as 12 to the 9th? In other words, can I multiply that 4 and 3 together first and then raise it to the 9th power? No. Because the 4 is not being raised to the power, just the 3. Okay? All right, the next one, it says the second and third terms are the ones we are missing. We are told it's geometric, which is important. If we don't have consecutive terms, right, we can't figure out if it's geometric. So they did tell us it was geometric. Our generic rule looks like that. What do we know? We know the first term. We could dump a 2 in for our first term. Do we know R? No. What other piece of information do we know that's going to help us? Say it again. All right, he's saying R has to be negative. Tuck at your tables for a minute. Why would R have to be negative? If you're multiplying and you go from a positive 2 to somehow getting to a negative 54, we had to change the sign. Agree? All right, so that's a good thing to be noticing. We should expect an R value that's negative. We are also told that this is my first term, right? I'm missing my second, my third. My fourth term, we know, is negative 54. Remember, the term's position is your n value. So when n is 4, we should be getting an answer of negative 54. So if we put a 4 in for n, we should end up with negative 54. Can we use that to figure out our R value? Yes. All right, what would I do first? Okay, dividing a 2 gets me negative 27. 4 minus 1 is just 3, so something cubed gets us negative 27. How do we solve that? Cube root it. What is the cube root of negative 27. Okay. So we must be multiplying by negative 3 each time. So to get the second term, can I take the first term times negative 3? Which gets me negative 6. To get the third term, I have a couple options. I can take the previous number, right? I can take that negative 6 and multiply it by 2. Sorry, by negative 3. We're getting 18. What's another way I could have figured out the third term? Okay, that's one way. He said divide negative 54 by negative 3. Work backwards, right? If I'm taking this term and multiplying by negative 3 to get that, I should be able to divide and go backwards. That's an option. What's another option? Say it again. I could change the n value. Go back to our generic equation. A sub n equals first term. We'll go ahead and plug it in here. We're looking for a sub 3, right? I could take the first term times my r value to the 3 minus 1 power. My first term was 2. My r value is negative 3. 3 minus 1 is 2. Negative 3 squared is 9. 9 times 2 is 18. So if I had said, give me the 20th term in the sequence, I'd probably go this route, right? Because then I could just put in 2 times negative 3 to the 19th power, and I got my 20th term. I don't need the ones in front of it. Okay? So multiple ways to get to that same answer. All right, this one we're looking for our second term. We are only given that the first term is 3, and the third term is 12. I'm going to pause the recording. I want you guys to see if you can work backwards and figure out your r value. All right, starting out, we know that it's geometric. We know that our first term is 3. And we know that our third term, so when n is 3, we should get a 12 for an answer, correct? Dividing the 3, we get 4 equals r squared, which means r could be what? It could be positive or negative 2, yes? What would we need to have in order to know which one it's supposed to be? We'd need a fourth term. We would need to see, is that pattern staying positive throughout? Is it alternating positive, negative? Okay? If we had been given another number, then we could figure out, are we multiplying by a positive 2 or a negative 2? At this point, we don't know that. So we would have to say our second term is our first term times either positive or negative 6, or sorry, positive or negative 2, which means we could have positive or negative 6 for a second term. All right. Did I skip one? Find an explicit rule for the nth term of the geometric sequence, given that the third term is 16 and the sixth term is 128. Do I have these in the wrong order? You have that one next, don't you? Okay, we'll do this one. It says, when a ball bounces, the heights of consecutive bounces form a geometric sequence. What are we told in our picture? Okay, so in a sequence notation, we could say the first bounce, the first term is 100, and the third bounce is 49. So can we figure out the pattern? They are then asking us to figure out the heights for the fourth and fifth bounces. Can we figure that out once we know R? All right. Do you agree with that setup? The third term is found by taking the first term times r to the 3 minus 1 power. All right. Third term is 49. First term was 100. We're multiplying it by r squared. What would we do? All right. So now I have 49 divided by 100 equaling r squared. Can I square root that fraction? Yes. How do you square root a fraction? Yeah, square root numerator and denominator. So r is going to be plus minus the square root of 49 1/100ths, which gets us 7/10. So my r value can be plus or minus 7/10. Now, does that make sense? What would happen if I multiplied by a negative r? My bounces would actually go into the ground, right? Would have a negative height. Can that happen? No. So because of the context of this one, we can figure out that we really just want the positive version of 7/10. Does that make sense? Okay. So if I want to know the fourth term, again, there's a couple ways I can do this. I could say a sub 4 equals the third term times an r, right? I can take the previous number times r. In this case, the previous number was 49. Multiplying by 7/10, what do we get? $34.3, okay? And that would be centimeters. What's another option I could have done? All right, so I could have gone back to the first term, right? Put in 100 here, multiplied by 7/10 to the 4 minus 1, to the third power. That would have also worked, okay? How do I find a sub 5? I can take my previous answer and multiply it by 7/10. Or again, another option is to take my first term times r, and 7/10 or 0.7, either way of typing it in your calculator is fine, to the fourth power. If I'm looking for the fifth term, what do we get for a decimal on that one? 24.01. So 24 1/100th of a centimeter. Okay. So back to this one. Find an explicit rule for the nth term. They are asking for a formula, right? We want a generic rule for any term in the sequence, given that the third term is 16 and the sixth term is 128. Normally, we go from the first term, we multiply by r to the n minus 1 power to get to the nth term. We're going to shift that a little bit. We're going to start with the third term, multiply it by r. How many times till we get to the sixth term? What would my power need to be to move from the third term to the sixth term? I'd have 6 minus 3 for a power, right? Here I had n minus 1. Now I'm going to have 6 minus 3. I have to make 3 jumps to go from the third term to the sixth term. Plugging in, we know the sixth term is 128 and the third term is 16. And we know we have 3 jumps. What would we do? Okay, what's 128 divided by 16? 8. 8 equals r cubed. So r would have to be 2, cube rooting them both. Okay, so we've got our r value. Can we write our rule? Almost. What 2 things do we have to know to write our rule? First term and r. We know r. Do we know first term? All right. So we're going to have to work back. We can work back from the 6th term or from the 3rd term. The 3rd term's closer, so let's go ahead and use that one. So the 3rd term would come from the 1st term times r to the 3 minus 1. My 3rd term was 16. We don't know our 1st term. We do know r is 2, and 3 minus 1 is a 2 for our power. Well, 2 squared is 4. If we divide the 4 over to the other side, our 1st term would have to be a 4. Okay, so let's write our generic explicit rule. A sub n equals what? 4 times 2 to the n minus 1 power. Okay? So given any two terms in the sequence, you can figure out your r value, you can figure out your 1st term. All right? The last little piece that we're going to look at. Do you remember when we did arithmetic sequences and we tried to find the number in between two other numbers? Yeah. What did we do? So we averaged them, right? It's called the arithmetic mean. We averaged the two numbers. For a geometric sequence, you have to find something called the geometric mean. So if we look at this sequence right here, 2, -6, 18, -54. To find a number in between the other two, you multiply the two together and square root it. Okay? Another way of saying that, if I take this middle number, -6, and square it, that's the same answer as the product of the two numbers on either side of it. Okay? So -6 squared gets me 36. 2 times 18 gets me 36. If I try to find the 18, 18 squared is the same as -6 times -54. Okay? So to find that missing number, I'd have to multiply the 2 on either side of it and square root that. Okay? So the geometric mean of any two positive numbers x and y is x times y square rooted. Again, there's a typo in your notes packet, so please change that. It should be the square root of xy. Now, there's a little note in here. When we ask you to find the geometric mean, it's always going to be a positive answer. So given any two terms in a geometric sequence, the term in between them, all right, the one that would be right in the middle, could be the geometric mean or its opposite. Okay, so the missing term could be positive or negative. You have to base it on what other pieces of information you're given. But technically, the geometric mean is just the positive version. All right? So what possible values could we have for the missing number here? We're going to use the geometric mean to find it. What do we do? Multiply the 48 times 3, and then what? Square root it. All right, so what is 48 times 3? And what is the square root of 144? So the geometric mean is 12, but the missing term could be what? Could be positive or negative 12. Yes? So my second term, the one I'm missing there, could be positive or negative 12. All right. Questions on geometric sequences? All right. There you go. Feel free to take a picture if you want.